So we have converted radians to degrees and degrees to radians. What we're going to do now is take those angle measures we've looked at and graph them and see where they fall and look at what their reference angle is. So first, for our angle measurements, and we typically refer to angle measurements as thetas or x's sometimes. Occasionally they use another variable, but theta is the most commonly used. Okay, so we always start measuring from the positive x-axis, so this side. Okay, so our angle measurements are more of like a rotation. So it's something started here, okay, and positive angle measures are rotated counterclockwise. So when you have a positive angle measurement, you're going counterclockwise. If they give you a negative angle measurement, that just means you're rotating the other direction. You're rotating clockwise. Now, a reference angle, that's the measure of the angle between the terminal side of an angle, so that's just where it ends up. So if I look at this angle measurement here, like let's just start with degrees because that's what we're familiar with. If I were measuring this angle measure, let's say it's about 250, so I would rotate this way. This side right here, this is called the terminal side. This would be the initial side where it started. Okay, so when they say terminal side, they mean wherever that angle falls. Okay, so what the reference angle is, it's the measure between the terminal side of the angle and the x-axis closest to it, which would be this x-axis right here. So this angle right here, that's our reference angle. I'm going to call it x in this picture. Okay, it is always positive and it's always acute. So a reference angle doesn't have a direction. So even if I give you a negative angle measurement, you would rotate in the clockwise direction, but that reference angle will always be positive. So let's look at a few examples. So we want to find the quadrant each angle lies in. We want to sketch it, indicating orientation, and find the reference angle. So we're going to start with degrees. That's something we're comfortable with. Okay, so 300 degrees. We know that's going to be in the fourth quadrant. Okay, so we're rotating in the positive direction. So 360 degrees is going to fall here. And when you're sketching these angles, like I know 300 is actually closer to the y-axis than it is the x-axis. My picture, it looks almost in the middle. What's important when you're drawing these is that they are in the correct quadrant. Okay, they don't need to necessarily be accurately at 300 degrees. You just want it in the right quadrant. So this right here, this little arrow showing me which way I rotated, that's the orientation. Okay, this little angle right here, this is called the reference angle. Okay, so it's how far this angle is from the x-axis. Well, that reference angle, that would be 60 degrees. This is 60 degrees short of 360. It's always the difference between the two. So this is 360, this is 300. 300 minus 60 gives us a 60-degree reference angle. So we've got the quadrant, which is 4, the sketch, the orientation, the reference angle. Okay. Now we're going to look at radians. We are going to deal mostly with radians. Okay, and you don't want to take every single angle measure and convert it to degrees and graph it, and then switch it back to radians for the reference angle. If it's in radians, you want to stay in radians. So before we go over these, let me just jump back to this picture. Okay, so we know we're starting here. So the right side of the x-axis, that is 0 radians. We know all the way around is 2 pi. So I start here, if I go all the way around, a full rotation, that's 2 pi radians. So that means halfway, this is going to be pi radians. So this is half of pi, so pi over 2. Okay. So this right here, we can see each quadrant is a pi over 2 radians. So this is 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. So the y-axis is 3 pi over 2. And then we could continue to rotate. This would be 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, etc. So you can continue to rotate more than once. Okay? But when you're trying to figure out where an angle falls, if you look, the x-axis is always the whole numbers. Okay, this side will always be the even numbers, this side will always be the odd numbers. And then your y-axis, those are always going to be the pi's over 2. Okay, and they'll both have an odd numerator. You just have to see where it falls on the y-axis. So the y-axis acts kind of as like our halfway point. So when I'm trying to graph something in radians, okay, I think of it as a mixed number. So I think of this as 1 1/4 pi. Okay. So when I graph it, I know 1 pi is the x-axis. Well, then you look at what's left over. That's 1/4. If what's left over is less than a half, you're not going to go past the y-axis. So that angle is going to fall in quadrant 3. So since this is less than a half, it's not going to push me past the y-axis. Had this been like 1 3/4, well, 3/4 is more than a half. So I would have 1 pi. 3/4 more is going to push you past that halfway point. Okay, remember the y-axis is always the pi's over 2. So that 3/4 would push us into the 4th quadrant. Okay. Now to find your reference angle, the easiest thing I think to do is look at this remainder. That's 1/4. That is how far past the x-axis we go. So this is 1/4 pi, so that makes our reference angle pi over 4. That's the difference between this. The difference between pi, this is 1 pi, and 1 1/4 pi. The difference between the two would just be a 4th. Okay, so that's pi over 4. So you put the pi back for the reference angle. Okay, and if it is given in radians, we always answer the reference angle in radians as well. So now we've got a negative angle. So I'm going to go ahead and convert this to a mixed number. So negative 19 over 2, 7 goes in there 2 times with 5 left over. So now I'm rotating clockwise. You're always going to start on the positive side of the x-axis. So I know 2 pi is going to get me all the way around. So this is negative 1 pi, negative 2 pi, and then I need to go 5/7 more. So 5/7 is more than a half. So since that remainder part is more than a half, that's going to push me past the y-axis. So this angle is going to fall right here. So this little circle is the angle, the one coming from the origin. Sorry, this little circle is the orientation. The angle coming from the origin, that's the actual angle. That's where it ended up. Okay. So we're going to be in quadrant 3, and my reference angle. Okay. If I look at this part that's left over, 5/7, that's more than a half. Okay, meaning it's more than pi over 2. So it's more than 90 degrees. That's not an acute angle. So if you look at this little part that's left, okay, if it's more than a half, you look at how much you have left to get to the next whole number. So that would be 2/7 in this case. If I go 2/7 more, that'll get me to the x-axis. So the difference between this angle right here and this x-axis, which would be like 3 pi if I were to continue, would be 2/7. So on number 2, the reference angle was a 4th. It was what was left over because it was less than a half. Here, since what's left over is more than a half, the reference angle is the difference. So it would be 2/7, which would be 2 pi over 7. So you always keep the pi in the reference angle. So the number 4, we've got negative 5 pi over 3. So that's negative 1 2/3 pi. So again, I'm rotating clockwise. So this would be negative 1. 2/3 is more than a half, so that's going to push me past the y-axis. So there's my angle. So it's going to be in quadrant 1. My reference angle is going to be this little angle right here. Okay, so 2/3, that's more than a half. So that means I have 1/3 more to get to the next whole number. Okay, so my reference angle is going to be 1 pi over 3. Now for number 5, we have negative 3 pi over 2. So that's negative 1.5 pi. Okay, so we're still going in the negative direction. So here's negative 1. 1/2. This is exactly a half. That means I'm going to fall on the y-axis. So anytime you have a pi over 2 or a whole number pi, it's always going to fall on one of the axes. The pi's over 2 will fall on the y-axis. The whole number pi's will fall on the x-axis. Okay? This is what we call a quadrantal angle. Okay, so you need to be familiar with that terminology. So this is a quadrantal angle, and that means it's not in a quadrant, and it also does not have a reference angle. So anything that's quadrantal, if I ask you what quadrant it's in no quadrant. If I ask you what the reference angle is, it doesn't have one. Now, number 6, 28 pi over 9. This would be 9 goes in there 3 times with 1 left over. So this is 3 1/9 pi. Okay. So I can already tell, since that what's left over is less than a half, that's going to be my reference angle. So I know my reference angle is going to be pi over 9. So you don't even have to graph them to find the reference angle if you don't need to. Okay. But to figure out what quadrant it's in, so now I'm going counterclockwise since it's positive. This is 1 pi, 2 pi, 3 pi, 1/9 more, since that's less than a half. I do not go past the y-axis. So this is going to be in quadrant 3. So on this next set, if you want to take a minute, pause the video and try these, all we're doing here is finding the reference angle. Okay, so to do that, you can graph them like we've been doing, or you can just look at what's left over. Okay. So here that's 1/6, which is less than a half. So that's going to be my reference angle. Okay, and always make sure you put that pi back. I don't usually write the pi just to make it quicker. But if the angle has a pi, the reference angle will also have a pi. 8, that is going to be -1 1/3. So again, 1/3 is less than a half. So that's going to be my reference angle. 10 pi over 7. 7 goes into 10 once with 3 left over. Well, 3/7, again, that is less than a half. So that'll be 3 pi over 7 as our reference angle. For number 10, this is going to be 3 3/5. Okay. 3/5 is more than a half. So that means my reference angle is going to be the difference to get to that next hole. So like 3/5 and 2/5, that makes 5/5 a whole. So since this is bigger than a half, we take the rest of it as our reference angle, the 2/5, so 2 pi over 5. Number 11, that's just -7/12. Okay, so we don't have a whole number, so we're just looking at the fraction. 7/12 is more than a half. So what's left, the 5/12, that will be my reference angle. Okay, remember, we never include the negative with the reference angle. It is always positive. Now, number 12, this is -2.5. Okay, so that's going to be quadrantal because our remainder is a half. Okay, so since this is quadrantal, there is no reference angle.